at the extremities of focal chord, prove that tangents at the extremities of the focal chord, prove that the tangents at the extremities of focal chord of a parabola intersect at right angles on the directrix. Intersects at right angles on the directrix. Prove that the tangents at the extremities of the focal chord of the parabola intersects at right angles on the directrix. Okay, right angles on the directrix. First of all, tangents at the extremities of focal chord. Extremities of focal chord. Focal chord means passing through focus. Okay, focal chord means passing through focus. Of course, example, problem number normal chord at the other than origin whose ordinate, page number 123, problem 3. Abscess are equal to ordinate method. Okay, here extremities of focal chord. Okay, first of all, focus S A, 0, focal chord PQ, tangents drawn at P and Q, forming 90 degrees at directrix. Okay, parabola intersects at right angles at the directrix. That means directrix, this point is minus A, 0. Now we can find out P and Q. Of course, P point 81 square, 281. Next Q point. Now parabola is y square equal to 4ax. Next, S focus, and P 81 square, 281 is extremity of focal chord. Focal chord means that implies x1 x2 equal to a square, y1 y2 equal to minus 4a square. x1 81 square, x2 point q 82 square, 282, that implies 82 square equal to x1 x2 equal to a square, y1 y2 equal to minus 4a square. y1 y2 equal to minus 4a square, that is 281 into 282 equal to minus 4a square, that is t1 t2 equal to minus 1, equal to minus 1. That implies P point is t1 t2 equal to minus 1. P point is 81 square, 281. t2 is minus 1 by t1. That is 82 square, 1 by t1 square, 282. t2 equal to minus 1 by t1, minus 2 by t1. Okay, that is Q point. Next, P, Q, R. R is minus a comma 0. Now slope of PR. Now slope of PR bar y2 minus y1 by x2 minus x1. A common out 2t1 by 1 plus t1 square. Next, slope of PR bar, next QR bar. QR bar y2 minus y1 by x2 minus x1. A cancel 1 by t1 y2 minus y1 x2 minus x1 2a t1 2a by t1. A cancel 2 t1 by minus 1 plus t1 square minus t1 square minus 2 t1 by 1 plus t1 square. Here slope of PR bar is PR bar R y2 minus y1 by x2 minus x1, that is 2t1 by 1 plus t1 square. Slope of QR bar is y2 minus 0 minus 2a by t1 minus a by t1 square. A common out 2 by t1 by 1 plus t1 square, t1 square 2t1 by minus 2t1 by 1 plus t1 square. Therefore m1 into m2. Here x1 x2 equal to a square, y1 y2 equal to t1 square t2 square equal to 1. y1 y2 equal to minus 4a square, 2a t1 2a t2 equal to minus 4a square, t1 t2 equal to minus 1, t2 equal to minus 1 by t1, t2 equal to minus 1 by t1, a by t1 square, 2a t2 minus 2a by t1. That is Q point. Parabola y square equal to 4ax. PR y2 minus y1 by x2 minus x1. QR slope y2 minus y1 by x2 minus x1. 1 plus t1 square 2t1 by 1 plus t1 square. Here a by t1 square 2a by t1, a by t1 square plus a t1 square LCM పైకి వెళ్ళిపోద్ది. 0 minus 2a by t1, 0 plus 2a by t1, that is t1 square, t1 cancel, 2t1 by 1 plus t1 square. Now problem is, equation prove that the tangents at the extremes of focal chord of parabola intersects at right angles on the directrix. Slope of this one into slope of this one is minus 1 అవ్వాలి. Okay na? Of course, if q becomes t1 square t2 square, if q is t2 square, a t2 square, a t1 square, q is a t2 square 2a t2, PR bar y2 minus y1 by minus 0 2a t1 by minus a t1 square, a cancel 2t1 by 1 plus t1 square. Similarly QR bar 2a t2 minus 0 by a t2 square plus a cancel 2t2 by 1 plus t2 square, that is m1 and m2, slope of PR bar and slope of QR bar into m2 2t1 by 1 plus t1 square, 2t2 by 1 plus t2 square, 4t1 t2 by 1 plus t1 square into 1 plus t2 square, t1 square t2 square, t1 square plus t2 square, t1 t2 equal minus 1, minus 4 by 1 plus 1, 2 plus t1 square plus t2 square, 2t1 t2, t1 square plus t2 square, because 1 plus t1 square into 1 plus t2 square, t1 square plus t2 square. t1 square plus t2 square equal to 4 because it is focal chord. t1 t2 equal minus 1. t1 square t2 square equal t1 square plus t2 square equal to 2. That is minus 4 by 2 plus 2. That is minus 1. Slopes m1 m2 equal to minus 1. Therefore, tangents at extremities of focal chord intersects right angles and the directrix. Right angles and the directrix. That is problem number 4 on the directrix. Okay, slope of PR bar, slope of QR bar is m1 m2. m1 into m2 equal to minus 1.
Find the condition for the line y equal to mx plus c. Find the condition for the line y equal to mx plus c, y equal to mx plus c be a tangent to the parabola, x square equal to 4ay. x square equal to 4ay. Find the condition for the line y equal to mx plus c be a tangent to the parabola x square equal to 4ay. x square equal to 4ay parabola. Any line y equal to mx plus c be a tangent. Okay. Now we find out the condition for tangent y equal to mx plus c to x square equal to 4ay. Given line y equal to mx plus c, parabola x square equal to 4ay, that implies y equal to mx plus c, that is x square equal to 4a into mx plus c, that implies x square minus 4a mx minus 4ac equal to 0. This is quadratic equation in terms of x, ax square plus bx plus c. Here given line touches the parabola. Therefore, there is only one root. There is only one root means discriminant equal to 0. Discriminant equal to 0 because only one root touches. Discriminant b square minus 4ac, b square minus 4ac, minus into minus plus 16ac equal to 0. b square minus 4ac equal to 0. 16 common out, 16a. am square plus c equal to 0. That implies am square plus c equal to 0. That implies c equal to minus am square. Therefore, condition is c equal to minus am square. That is condition for tangent y equal to mx plus c to the parabola x square equal to 4ay. Condition for the line y equal to mx plus c to tangent to parabola x square equal to 4ay, that is x square equal to 4a into y means mx plus c. Transform to left side. X square minus 4a mx minus 4ac equal to 0. Only one root. Discriminant equal to 0. b square minus 4ac equal to 0. That is c equal to minus am square. అదే y equal to mx plus c tangent to y square equal to 4ax అయితే c equal to a by m. Here parabola x square equal to 4ay. Therefore, c equal to minus am square. Standard form y square equal to 4ax ki c equal to a by m. Here c equal to minus am square. Next, 3 normals are drawn from k comma 0. 3 normals are drawn from k comma 0 to the parabola y square equal to 8x, to the parabola y square equal to 8x, and one of the normal to the parabola y square equal to 8x. One of the normal is the axis. One of the normal is axis, and remaining two normals perpendicular. Remaining two normals perpendicular to each other. Then find the value of k. Perpendicular to each other. Then find k. Then find k. 3 normals are drawn from k comma 0 to the parabola y square equal to 8x, and one of the normal is axis, and remaining two normals perpendicular to each other. Then find the value of k. Okay. First of all, normal means equation of the normal. Equation of normal to y square equal to 8x is y equal to mx minus 2am minus am cube. Here a equal to 4a equal to 8 to a equal to 2. Therefore, normal is y equal to mx minus 2am minus am cube. Y equal to mx minus 2a minus 4m minus 2m cube. That is passing through point k comma 0. Passing through point k comma 0. Point k comma 0. Therefore, x place lo k, y place lo 0. That is 0 equal to mk minus 4m minus 2m cube. That implies 2m cube plus 4m minus mk equal to 0. That implies 2m cube, m common out, 4 minus k equal to 0. Here trinomial alpha, beta, gamma are roots. Sum of the product of two roots m1 m2 plus m2 m3 plus m3 m1 equal to m coefficient 4 minus k by m cube coefficient 2. 4 minus k by 2. Now, one of the slope is axis. Axis means axis of the parabola, x-axis. X-axis, that means m1 equal to slope of x-axis 0. Next, other two product equal to minus 1 because other two slopes perpendicular to each other. Other two lines normals perpendicular to each other. Substitute m1 equal 0, m2 m3 minus 1, m1 into 0. That implies 4 minus k equal to minus 2, k equal to 4 plus 2 6. k equal to 4 plus 2, 6. Okay, that is problem. The three normals drawn from k comma 0 to the parabola y square equal to 8x. Y square equal to 8x. First one normal is xx and remaining two normals perpendicular to each other. Then find k. Equation of the normal to y square equal to 8x is y equal to mx minus 2am minus am cube. In this there are three normals, three slopes, m1 equal to 0 and the remaining two normals perpendicular to each other, m2, m3 minus 1. That normal passes through k comma 0. This is equation number 1. 1 passes through k comma 0. Substitute x plus k, y plus 0, we get 2m cube plus m into 4 minus k equal to 0. This is trinomial in m's. Therefore, sum of the product of two roots, m coefficient by m cube coefficient. m1 equal to 0, m2, m3 minus 1, that implies 4 minus k equal to minus 2, k equal to 4 plus 2, 6. That is problem 6th one. 7th one. 7th one. Show that the locus of point of intersection of perpendicular tangents to the parabola y square equal to 4ax is directrix x plus a equal to 0 is the directrix x plus a equal to 0. Point of intersection of perpendicular tangents. Is the directrix x plus a equal to 0. Given parabola stand form, no problem, y square equal to 4ax. The locus of point of intersection of perpendicular tangents. There are two tangents which are perpendicular. Okay, locus of point of intersection of perpendicular tangents. There are two methods. In objective method, it is very shortcut, only 3 steps. In IP method, more than 3 steps. Okay. First of all, IP method, show that the locus of point of intersection of perpendicular tangents to the parabola y square equal to 4ax. Tangents. Equation of tangent. Equation of tangent to y square equal to 4ax is y equal to mx plus a by m, because c equal to a by m. Next, perpendicular. Another tangent is perpendicular. Equation of tangent which is perpendicular to this one. Equation of tangent which is perpendicular to y equal to mx plus a by m is perpendicular slope minus 1 by m. Y equal to minus 1 by mx, a by minus 1 by m. C equal to a by m, a by minus 1 by m. That is my equal to minus x minus am square minus am square. From this y equal mx plus ay. Next, my plus x equal to minus am square. Equation number 2. Here, y minus mx equal to a by m. A by m. Squaring and adding. Squaring and adding. This is 1. This is 1. Squaring and adding. 1 square plus 2 square, we get y minus mx whole square my plus x whole square equal to a square by m square m square y square common out 1 plus m square m square 1 plus m square 2ymx cancel 2ab plus 2ab minus 2ab cancel. Next, a square by m square. Here perpendicular slope a by minus 1 by m minus ma m LCM minus m square a my equal to minus m square a square m square. This is y equal to mx plus a by m. Y minus mx equal to a by m. Y minus mx whole square equal to a square by m square m square by m square. That is 1 plus m square common out అవ్వాలి. Or eliminate m from 1 and 2. Eliminate 1 from 1 and 2. If we add, we get 1 minus m, 1 plus mx, a by m minus am square, 1 by m minus m square. M cross multiplication, we get my minus m square x. My minus m square x equal to a. My minus m square x equal to a. From 1 becomes my minus m square x equal to a. Cross multiplication, my minus m square x equal to a. 2 minus 3, my cancel, x common out 1 plus m square minus a 1 plus m square. 1 plus m square, 1 plus m square cancel, x equal to minus a. Therefore, locus of point of intersection is x plus a equal to 0, which is directrix. That means there are two tangents, angle between them is perpendicular tangent, locus of point of intersection of perpendicular tangents, axis. Therefore, angle between them is 90 degrees. This locus point of intersection is directrix. Okay. That is IP method. In objective method, angle between two tangents, tan theta by 2 equal to tan theta by 2 equal to root any point px1 y1. Okay. Root s11 by 2a tan pi by 4 1. y1 square minus 4a x1 or tan theta by 2 equal to angle between two tangents tan theta equal to m1 minus m2 by 1 plus m1 m2 tan 90 pi by 2 tan 90 tan pi by 2 1 by 0 infinity. Cross multiplication, we get m1 m2 equal to minus 1. From this equation of tangents by m square cross multiplication, m square x minus my plus a m square x minus my plus a. Therefore, product of the slopes is c by a by x equal to minus 1, that is x equal to minus a, that is directrix. Because tan theta equal to modulus m1 minus m2 by m1 minus m2 by 1 plus m1 m2. m1 m2 equal to minus 1. Because tan 90 infinity, something by 0, cross multiplication 0. m1 into m2, product of the slopes. From this, y equal to mx plus c means a by m. Product of the slopes, c by a by x equal to minus 1, that is x equal to minus a. Okay.